So in the last lesson, we did limits for the rational functions and polynomials. Now as some students had asked, so we are doing the limits for exponentials. So first we'll go through the basic concept. Let me draw the graph for ex and negative ex. So we see that as x tends to infinity, ex also goes to infinity, and as x tends to negative infinity, ex goes to 0. You can see as it goes to negative infinity, it is 0. Then limit x tends to infinity, e minus x, it goes to 0, and limit x tends to negative infinity, we can see here e raised to power minus x goes to infinity. So we'll keep these in mind while doing the questions. So if another concept is, if the exponent of an exponential goes to infinity in the limit, then the exponential function would also go to infinity. And if the exponential goes to negative infinity, then the exponential will go to 0 in the limit. Okay. So like e raised to power a. So if the exponent of the exponential goes to infinity, if a goes to infinity, then the function also will go to infinity. Okay. And if exponential a goes to negative infinity, then function will go to 0 in the limit. So this is just a concept. We'll go over it while doing the problems. So the first question is, let x tends to infinity and e square minus 6x minus 10x square. Okay. So here the exponent goes to minus infinity in the limit. The exponent is this. So it goes to minus infinity in the limit. So the exponential must go to 0. And why this goes to infinity? As limit x tends to infinity, this goes to minus infinity. Because we use the infinity property here, limit x tends to positive negative infinity. Okay, axn. Okay, this will give negative infinity if a is less than 0 and n is even. Okay. So this is, so here it is minus 10 and x square. So here a is negative 10. Okay. In this case, a is negative 10 and n is 2. So this a is negative 10 and this goes to infinity. It means if the exponent goes to negative infinity, then in the limit, then the exponential will go to 0 in the limit. So this would be x tends to infinity e 2 minus 6x minus 10x square will be equal to 0. Now we'll try one more problem like this. So here it is given limit x tends to negative infinity and e x minus 5x4 plus 1. So in this case, applying infinity property, so limit x tends to plus minus infinity is axn and plus bx plus c. So this gives infinity if a is greater than 0. Therefore, the exponent will be limit x tends to negative infinity and 6 minus 5x 4 plus 1. This is equal to infinity. So the exponent goes to infinity in the limit, and so the exponential will also go to infinity. So exponent part is going to infinity here. So the exponential part also goes to infinity. Now I'll try to do the next problem which somebody has sent. So t tends to infinity and e raised to power 12t minus 4 e raised to power 6t plus 3et plus 2 e raised to power minus 2t negative 9 e raised to power negative 15t. So if I directly put infinity, you will see that this gives infinity, this gives minus infinity, this will be plus infinity, and since this is negative and we know here that this gives 0, okay, and this gives minus 0. We knew the graph was like this for ex, okay. So In this case, so this was the graph for Ex, this is the graph for negative Ex, and we see that when this negative exponentials will give 0, so they are not the cause of worry. Infinity minus infinity is indeterminate. So what we'll do in this case is we will take out the last two, 0 minus 0 are not indeterminate, hence they are not a problem. So what we do is we factor out the highest power. So in doing so, all the remaining have negative exponents, and the limit of those will be 0, and then we'll not have any problem. So let's do t raised to power infinity, and we take the highest power out, we factor out. So this is, and this will be 1 minus 4. This gives minus 6t plus 3. So this is minus 11t, and this gives 2 e raised to power minus 14t plus negative e raised to power minus 27t. So we know now if we find limit t tends to infinity, e raised to power 12t and limit t tends to infinity, 1 minus 4 e minus 6t plus 3 e minus 11t plus 2 e minus 14t negative 9 e minus 27. So this will give us infinity, and this will give us 1, and all these are 0, we can see from here. So 0 plus 0 plus 0 minus 0. So they will not, so when they will not cause a problem, and now infinity into 1 will give us infinity. So when we are dealing with the problems like t tends to infinity, we take the largest positive component because they are only causing a concern. If we are, and so all of these become negative, and negative infinity it gives 0. So we have only one infinity here to deal with. Now if for the same problem we have to find the limit t tends to negative infinity and e raised to power 12t minus 4e 6t plus 3 e raised to power t plus 2 e minus 2t negative 9 e raised to power a negative 15t. So now in this case only the exponents with the negative We again see the graph. If we take out the limit, see, this is the graph of Ex and this is the graph of e raised to power negative. So if we see t tends to negative infinity, the positive here doesn't make doesn't cause a problem because it is 0. Okay, but the negatives, they give us infinity. These two are infinity. We can see when it is negative. So we want to get rid of these problems. So we factor out the largest, uh, we factor out the largest exponential and largest, by largest we mean the distance from 0. So that is here negative 15. So t raised to power this is negative 15t. So this gives e raised to power 27t minus 4e 21t plus 3 negative 14t, sorry, 14t, and this is plus 2. So this is 13t and this will give negative 9. So now if we find the limit, so this will be limit t tends to infinity e minus 15t and limit t tends to infinity e 27t minus 4 e 21t plus 3 e 16t plus 2 e raised to power 13t minus 9. So we know as we see this graph, this gives us as t tends to negative infinity, this gives us infinity, and this will just, as we see this, when these go to negative infinity, they just give 0. So these will give 0 minus 9. So minus 9 multiplied to infinity would give us negative infinity. Now we'll do the next question as someone has asked. So this is 6 plus e minus x and 1 minus e minus x. So again, we see these graphs of e raised to power x, and this is e raised to power minus x. So this is limit x tends to infinity 6 plus e raised to power minus x. And by so this gives us 6, and as we see here, limit x tends to infinity e raised to power minus x is 0. So we get the numerator 0. Now let us do denominator. So limit x tends to infinity 1 minus e minus x. So this gives 1, and in the graph of e minus x, as it goes towards infinity, it is becoming 0. So this is, we know we can write this like 6 plus e minus x, and limit x tends to infinity. We know this is a property of limit laws, that we can find the limit of denominator and numerator separately. And then when we substitute the values, this will be 6 plus 0, 1 minus 0, which is 6. Now, for the same question, let us try when we do limit x tends to negative infinity and 6 plus e minus x and 1 minus e minus x. So we can simplify this by putting 1 over, or we can multiply numerator and denominator with ex. So c plus e minus x multiplied to ex and 1 minus e minus x multiplied to a raised. So 6 ex plus 1 ex minus. Okay. So now if we can find the limits of denominator and numerator separately as per the limit laws. We can do that. And so limit x tends to infinity 6 ex plus 1, which is equal to limit x tends to infinity 6 ax. So this is This is negative infinity. So as Ex, sorry for this, I'll just, so this is negative infinity, and infinity. So this, we know as we see the graph, this will become 0 and this is 1, and here for this it becomes limit x tends to negative infinity e raised to power 6 plus negative x tends to negative infinity and 1. So this gives 0 minus 1. So limit x tends to negative infinity 6 plus 1 x. This gives 1 or negative. So our final answer is negative 1. So please feel free to text me if you have any doubt about these. Thanks. We'll meet in the next class.